Hello and welcome to Real Civil YouTube channel. Look at this beam which is loaded, and these are the shear cracks. So you can see the shear cracks over the support, and if you see clearly, they aren't breaking straight up and down. The cracks are not straight, but they are inclined. You can see here, and the angle is almost 45 degree. If shear force is, we know that we show the shear force like this, right? If the shear force is pushing vertically down on this beam, why isn't the crack vertical? Why does shear force create a diagonal fracture like this? You can see here a diagonal fracture line. So in this video, we are going to break down the exact stress state that caused this. Okay, so I'll just clear this. Yes, now you can see clearly the cracks. To understand this, we have to zoom in on a tiny square element inside the web of the beam right where the shear force is highest. We know that shear force is highest over the support, and if you see cross section wise, we know that at this center or at the neutral axis the shear stress is maximum. So we will consider a tiny square. Okay, I will draw here the same square. This is the part of the beam, okay, which we have taken from here, where there is a maximum shear. To understand the concept, okay, when load is applied, a vertical shear tries to push up one side down and the other side up. So if you take the section, the reaction is upward, but the load is downward. So I can show here, this is the reaction and this is the load. Okay, now you can see this is forming an anti-clockwise couple. Okay, so in order to balance it, or to keep that tiny block from spinning in a place, equal horizontal shear stress develop along the top and bottom. That means you can see here, one force is upward, another is downward, so they are forming an anti-clockwise couple. In order to balance this, there is a clockwise couple that gets formed like this. Okay, now what happens here, you can see at this point, they this is tension, this point again tension, because these two forces are pushing, and at these 2 points it is getting compressed. So generally what happens, the same square I will redraw again here, and we know that these 2 points are getting stretched and these 2 points are getting compressed. Okay, so what happened, so this tiny square tries to took this shape. Okay, that means tension on this diagonal, whereas compression on this diagonal. Okay, and we know that a material like concrete are very strong in compression but extremely weak in tension, often failing at just 10% of the compressive strength. Okay, so we can see here, this is the tension. Okay, so crack always open up perpendicular to the direction of maximum tension. That's why the cracks are occurring like this. Since the maximum diagonal tension pulls at 45 degree, the cracks open perpendicular to the pull, resulting in the classical 45-degree inclined shear crack you see right here. That's why the cracks are like this. It's tear up because the concrete is weak in tension. So you can see here the cracks. So that is the reason why cracks are inclined or at an angle of 45 degree. In next video, I am going to show you why in the bending the cracks are vertical. Thank you. If you have any doubt, you can ask me. Please like, share, subscribe the channel. Thank you. Thank you so much.